Hi, ladies and gentlemen. Let me wholeheartedly welcome you to the 12th session on ECT 204 Signals and Systems. In this video, we see more about the discrete convolution. So the contents of today's session are your learning outcomes, linear discrete convolution, and the summary of understanding. So what you will learn in this video, or you will learn discrete convolution with examples. Then you will identify the discrete convolution with the multiplication of numbers, and you will understand the relation between convolution and multiplication. You have seen discrete convolution in your school classes when you learned multiplication. You have done it like a discrete convolution. Then you will relate the length of the convolution with the length of the sequence. So suppose I convolve a sequence of length m with a sequence of length n. What will be the length of the total convolution? Then you will appreciate a demo of discrete convolution with Python. The discrete convolution between sequences hn and xn is expressed as xn convolution hn, that is k from minus infinity to infinity xk hn minus k, or it can be k from minus infinity to infinity hk xn minus k. It can be anything. Let the sequences xn be 1, 2, 3 with origin here at 1 and hn equal to 1 minus 1. Now what happens is, if you look into this equation, you can see that the one sequence x that is kept as such, the other sequence is flipped in time, that is hk is converted into h minus k, that is time reversed, then is shifted in time and then multiplied and summed together. The flipped sequence is shifted and the dot product is taken for every shift to get the output sequence. So what happens is, this is my xn, say 1, 2, 3. These are this is 0, 1, 2. These are the values 1, 2, 3. And h minus n, hn is actually 1 minus 1. So h minus n will be minus 1, 1. So this is a minus 1, 1. This is h minus n. Now what happens is, this is the case with h minus m will look like this. So yn will be, this is the case without any shift. This is xk and this is h minus k. So what happens is, this is the case with n equal to 0. So what happens, yn output will be, here there is a one overlapping value here 1. So this is minus 1 into 0 plus 1 into 1 plus 2 into 0 plus 3. So that will be a 1. Okay. And if I shift by 1 unit to the right, if I shift to the left, there won't be any output. If I shift to the left, what will happen is, this minus 1 will coincide with this 1. So it is minus 1 into 1 plus 1 into 2, that will be a 1. Okay. If I shift one more point to the right, what will happen? That is, for n equal to 0, 1, 2, n equal to 2, what will happen? Minus 1 will come here. So it will be a minus 1 into 1, then plus this minus 1 will come here. That will be minus 1 into 2 plus 3 into 1. So 3 minus 2, it will be a 1. If I shift one more time, this what will happen? This minus 1 will come here. Minus 1 will align with 2 and next value will be 0. So it will be a 3 into minus 1. So this will be a minus 3. So the output sequence will be 1, 1, 1 minus 3. So this, instead of doing this graphically, you can do it very quickly by as a table like this. This is sequence 1, 2, 3, and this is sequence 4, 5, 6. Say I have to do the convolution between 1, 2, 3 and 4, 5, 6. So the first sequence is 1, 2, 3 and this 4, 5, 6. First you have to multiply by this 4. So that is without any shift. This is for n equal to 0. So just like your school class multiplication, it becomes 4 into 1. This is a 4. 4 into 2 is an 8. This 4 into 3 is a 12. Then n equal to 1, there will be one shift, that is for this. So that will be a 5 into 1, then 5 into 2, 10, then 5 into 3, that is a 15. Then there's a multiplication by 6, that is 6 into 1, then 6 into 2, that is 12, that is 6 into 3, that is 18. Then, unlike the school classes, you don't carry over. Instead, you add them together. This is a 4, this is 8 plus 5 is 13, this is 12 plus 10 plus 6, that is a 28, and this 15 plus 12, that is a 27, this 18. So this output sequence will be 4, 13, 28, 27 and 18. Only thing is, in school classes you just carry over. This is just like the school class multiplication you studied. Note that, and this is equivalent to the multiplication of the numbers 123 and 456, because The number 123 is the polynomial 3x raised to 0 plus 2x raised to 1 plus 1x square with x equal to 10. This is a decimal representation. And 456 will be 6 into x raised to 0 plus 5 into x raised to 1 plus 4x square with x equal to 10. Now what happens is in the convolution in the time domain means multiplication means you actually multiply these two polynomials, take the resulting polynomial and put x equal to 0, x equal to 10 in that resulting polynomial. But instead you do a simple convolution in the school classes to do this multiplication. So here you can see that this multiplication, this x is nothing but the frequency of the system, because decimal system has a frequency of 10. 0, 1, 2, 3 up to 9, then again 0 comes. So that periodicity is 10. So its frequency is 10. So a multiplication in the frequency domain that is equivalent to a convolution in the time domain or in the discrete domain. Here this is a convolution. So this is equivalent to a multiplication of these two polynomials in the frequency domain. So again you can observe another observation. Here the length of the sequence is 3, here the length of the sequence is 3. So the length of the resulting sequence is 3 plus 3 minus 1, that is 5. That is 6 minus 1, 5. Here if you see length of this sequence is 3, length of this sequence is 2. So length of the resulting convolution is 3 plus 2 minus 1, that is a 4. Now that's an important result. Observe that if the length of the one sequence is m and the other is n, the discrete convolution has a length of m plus n minus 1. Now we will observe a demo of this convolution with Python. Here this is the first case, 1, 2, 3, first sequence is 1, 2, 3 and h is 1 minus 1. We will observe this convolution. Only thing is it is put as a discrete value with in the graph with the command grid, with the command stem. So I will open a terminal here. I will zoom it a little and I will instantiate a Python there. I will run con1. Now you can see these sequences. This is sequence 1, 2, 3 and this is sequence minus 1, 1, 1 minus 1. Okay. Now the resulting convolution is 1, 1, 1 minus 3 as we have said in the problem. Now here this sequence has a length of 3, this has a length of 2, so this has a length of convolution has a length of 4. Now we will see the second code. We will appreciate the code first. No, that is not our code. No more convolutions are there. Yeah, this is the only code in that. So you have observed this convolution. Now let us see another example, that is with xn is say I have a sequence say xn is alpha raised to n un. Consider convolution with itself. That is xn convolved with itself. What will happen? And you have to compute minus infinity to infinity yn, where yn is a convolution with of x with itself. Now what is the sequence? This is a sequence 1 alpha alpha square etc. It is convolved with the same sequence 1 alpha alpha square etc. So if you do as you did in school classes, this becomes 1 alpha alpha square, this becomes alpha alpha square alpha cube etc. The third line becomes alpha square alpha cube etc. So when I add up, what happens is the first value is a 1, this is a 2 alpha, this is a 3 alpha square, this is a 4 alpha cube etc. So if I want to compute this yn, sigma yn, what will happen? Sigma yn, suppose the sum is sigma yn, that is minus infinity to infinity yn, it will be 1 plus 2 alpha plus 3 alpha square plus 4 alpha cube plus etc. So I can write this as 1 plus alpha square etc. plus this alpha, this out of this 2 alpha I get 1 alpha here, alpha plus 2 alpha square plus 3 alpha square etc. Okay, I rewrite this equation. So this is this 1 plus alpha square etc. up to infinity by binomial series, it is 1 by 1 minus alpha. And this is nothing but alpha into 1 plus 2 alpha plus 3 alpha square etc., which is nothing but my original sequence S. So this is nothing but alpha S. So what happens is this alpha also come to this side. So this becomes a 1 minus alpha into S. This becomes 1 by 1 minus alpha. Or the resulting sum sigma yn or S is 1 by 1 minus alpha whole square. Okay, 1 by 1 minus alpha whole square. Now we will see if this code exists here. Yeah, I think this is the code for that. This is with alpha equal to 2, 0.2, and let us run this code. Here you can see that this is my xn, it is convolved with itself, and you get a signal like this. Let us compute what is this? We will compute sum z. I think we are looking at a different code. We will see. Yeah, this is our code actually. Oh, I'm sorry about that. This is with these are two exponential signals here. This was a different code. Okay, this corresponds to the problem last discussed. This is t equal to 0 to 500. Alpha is 0.5 and x is alpha raised to t. So this is a convolution between x and itself. If I look at the sum of z, that will be 1 by 1 minus alpha square. So we will run this conv 3. You can observe the convolution. This is the this alpha raised to n function. This is a convolution with itself. Okay. Now let us compute the sum z. The sum z should be 4. You can see that it is 4. It is 1 minus alpha, 1 by 1 minus alpha square. It should be 1 minus alpha raised to minus 2. You can see that it is 4. So the sum of the convolution is 1 by 1 minus alpha whole square, as we did in the problem. So we demonstrated this problem with the Python. Now coming to the end, the summary of understanding. Here in this video you understood the discrete convolution with examples. Then you understood the relation between multiplication and convolution. That is, a time domain convolution appears as a frequency domain. Time domain convolution appears as a multiplication in the frequency domain. Then you related the length of the convolution with the length of sequence. If the length of the sequence are m and n respectively, then resulting convolution will have a length of m plus n minus 1. Then you appreciated the demo of discrete convolution. And that is the end of this presentation. I thank you all.